Hello everyone! Today we are building something really cool, a classic analog clock using Python and Pygame. By the end of this tutorial, you'll have your own working clock that you can proudly show off. This is a fantastic little project you can complete in a single evening, and it is perfect for learning some key Python and Pygame concepts while creating something practical and fun. Remember, to become a good programmer, it is essential to build as many projects as possible, even simple ones. Each project teaches you something new and helps you grow as a developer. Let's jump in and start coding. Today we are making a cool analog clock. I know it might look tricky, but don't worry. We are going to break it down into 8 super simple steps. Trust me, by following along, you'll have your own working clock before you know it. Before we start with step number 1, make sure you are comfortable with Python basics like variables, loops, and functions. If you are new to Python or need a refresher, I've got you covered with my free Python basics course. Link is in the description. We'll also be using object-oriented programming to keep our code clean and organized. If object-oriented programming seems challenging or you want to master it, check out my comprehensive object-oriented programming course where I break down everything you need to know, also linked below. Now let's start with step number 1, getting Pygame ready to go. Pygame is a Python library used to create games and multimedia applications. In this tutorial, we will be using the Pygame Community Edition, a fork of the original Pygame library that is updated constantly with new features and bug fixes, and it is faster than the original Pygame library. However, you can also use the standard Pygame library if you prefer, as the code we will be using is exactly the same. To install the Pygame CE library, all we have to do is to open a terminal window and type the following command: pip install pygame-ce. With the Pygame library installed, we can now verify that it is working correctly by running a simple test script. To do this, we create a new folder. Let's call it analog clock, and then we create a new Python file in it and we name it main.py. Now we can open this file with our favorite editor. I'll be using Sublime Text in this tutorial. Inside the file, we have to import Pygame by typing import Pygame. Next, we have to run the program to see if Pygame is installed correctly. In Sublime Text, simply press Ctrl+B to run the program. If you see the message Pygame CE, our installation is working fine and we have successfully completed step number 1. That was easy, wasn't it? The next step in building our analog clock is to create a blank screen and set up the main loop. Before we start, it is important to understand the structure of today's project. It consists of 2 parts. The first part of the project is where we define our variables and initialize essential objects like the clock. The second part is the main loop, which is responsible for displaying the clock and updating the time. The main loop is like the heartbeat of the project, running repeatedly until the project is closed. In each iteration of the main loop, we will get the time and we will update the clock hands. Now let's create a blank screen and the main loop. First of all, we need to initialize Pygame, so we type pygame.init. Then we create a display surface. A display surface is like a black canvas where we can draw our objects. We need to specify the width and the height of the display surface. I am going to use a size of 600 by 600 pixels. Let's create the display surface. First, let's create 2 variables to hold the screen width and screen height for our game. Window width is equal to 600 and window height is equal to 600. Now we can create the display surface. Window is equal to pygame.display.setMode, parentheses, again parentheses, window width, window height. This line of code creates a display surface object named window. The setMode method takes a tuple as an argument. The first value is the width and the second value is the height of the display surface, our canvas. In simpler terms, we just created the main window, and to draw on it, we use a coordinate system similar to the one taught in high school. Each point on this window has its unique x and y values. The coordinate system used in computer graphics differs from the standard Cartesian coordinate system taught in high school. In computer graphics, the origin of the display is located at the top left corner, with 0, 0 being at the top left. In contrast, the standard Cartesian coordinate system starts from the bottom left corner, with 0, 0 being the origin. In this system, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move up. However, in the top left corner coordinate system used in computer graphics, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move down. This means that a point at 10, 10 will be located 10 units to the right and 10 units down from the origin. We will be using the top left corner coordinate system today. That's why it is important to understand the differences between these two coordinate systems. Now that we have created the window, we need to give it a title. We do that by using the setCaption function. Pygame.display.setCaption (quotes analog clock). Next, we create a clock object like this. Clock is equal to pygame.time.clock. Be careful here. Clock must start with a capital C because it refers to a specific class in the pygame.time module. It is important to note here that this clock object won't be used to get the current time. Instead, we will rely on Python's built-in datetime module to fetch the system time. This clock object is used to control the frame rate of our program. Don't worry about this line of code now. We will get back to it in a minute. The basic setup of our project is now complete. Let's now work on the main loop. The main loop consists of three parts. First, event handling. First, we check for any events, such as the user attempting to close the application or interacting with it, for example, pressing some keys. This is managed using Pygame's event handling system. Second, updating. Next, we update the state of our clock. This involves retrieving the current time from the system. Third, drawing objects. Finally, we draw the clock components, including the face and the hands in their updated positions on the screen. This step uses Pygame's graphics functions to render the clock visually. By following these three steps, we create a dynamic analog clock that continuously updates in real time and reflects the system's current time. Now let's implement these three steps. We will start by adding a comment to organize our code. Main loop. We start the main loop with a while loop like this. While true, colon. This while loop is an essential part of our project. It runs continuously until we close the app. At each iteration of the loop, we perform three key steps: checking for events, updating the state of the analog clock, and drawing the clock. Let's place some comments to help us organize our code inside the main loop. 1. Event handling goes here. 2. Updating state of the analog clock goes here. And 3. Drawing the clock goes here. It is important to note that before running the project for the first time, we need to ensure that the code inside the while loop has been fully written. If we run the code at this point, the while loop will run forever, since we have not defined a way to stop its execution. So in the next step, we will add the necessary code to stop the while loop. 4. Event in pygame.event.get (:). This line of code gets all the events that Pygame recognizes and happened since the last time the while loop ran and puts them in a list. Then we loop through the list of events and check if any of the events is the quit event. The quit event is when we click on the close button of the window. If the event is the quit event, we break out of the while loop. If event.type equals pygame.quit : pygame.quit. And then we have to close the program completely with the command sys.exit. This command is part of the sys module, so we have to import it like this. In the first line of the code, after importing Pygame, we type sys. That's it. Now we have defined a way to exit the app, but we need a couple more lines of code before running our app for the first time. We have to update the screen with this line of the code, pygame.display.update. This line of code takes all the changes we made in the object of our app and draws a picture from them. Since we haven't created any objects yet, this line just draws a blank screen. Remember the clock object we created at the beginning. It's time to put it in use. We need to inform the clock object about the maximum speed at which our app should run. This is done through the tick method. The tick method requires an integer argument which represents the maximum number of frames per second we aim to achieve. Typically, games run at 60 frames per second, but for our project, we will set it to 15 frames per second. 15 frames per second is enough for our analog clock because the clock only needs to update once every second to move the second hand. Using a higher frame rate, like 60 frames per second, would waste computer power without making the clock look any better. So, to limit the FPS to 15 FPS, we type clock.tick15. That's it. This means that the while loop and all the code inside it will run 50 times every second at most. This setup doesn't guarantee our app will run at exactly 15 frames every second. Rather, it sets 15 frames per second as the ceiling. This means our simulation won't run faster than 15 frames per second, but it could run slower, depending on the system's capabilities and the complexity of the scene being rendered. Now that the main loop is complete, we can run the simulation for the first time. As you can see, nothing is inside the window because we haven't drawn anything yet. But the important thing is that we can see the window with the title and the dimensions we defined, and that we can reliably close the app by clicking on this X icon here. Beautiful. The app window is black. Let's make it a light blue color. Pygame provides several built-in colors, but we will be defining our own colors today. In Pygame, colors are represented as a tuple of 3 values, each representing the amount of red, green, and blue in the color. The values for each component range from 0 to 255, where 0 represents the absence of the color and 255 represents the full intensity of the color. For example, to create a red color, we will create a tuple with the following values. Red is equal to parenthesis 255, 0, 0. These values represent the red, green, and blue components respectively. So, to create a light blue color, we will create a tuple like this. Light blue is equal to parenthesis 225, 239, 240. Now let's paint the clock window light blue. Inside the main loop, before updating the window, we call the fill method of the window object like this. Window.fill parenthesis light blue. The fill method just fills the display surface we have created, our canvas, with the color we define, in this case light blue. If we run the project now, we can see the app window is now light blue. Beautiful. We just completed a very basic main loop, so we can remove step number 2 from our list. We have made progress. Now, let's work on step number 3. Let's design our clock face. An analog clock is made up of several key parts, each playing an important role in displaying the time. Let's take a moment to understand the structure of the clock as a whole before we dive into creating its face. Our analog clock will consist of the following components. 1. Clock face. This is the foundation of the clock. It includes the outer rim, the main face, and the hour markers. It serves as the base for the clock hands and helps the user read the time easily. 2. Clock hands. These include the hour, minute, and second hands. Each hand will rotate around the center of the clock and update dynamically to display the current time. 3. The center dot. This small dot in the middle of the clock serves as the pivot point for the hands, answering them visually to the face. Now that we understand the overall structure of the clock, let's focus on creating the clock face, as it forms the foundation for everything else. Here is what we will build in this step. 1. The outer rim. This gives the clock its bold, circular outline. To make it visually interesting, we will use a two-tone design with a dark gray outer layer and a light gray inner layer. This layering adds depth and makes the clock look polished and professional. 2. The main face. Inside the rim, we will add a white circle that acts as the clock's background. This clean, neutral base makes the hands and the hour marks easy to read. Let's start. In this project, we are going to use object-oriented programming to help us organize our code. In object-oriented programming, we group related data and functionality into classes, which makes our code more modular, organized, and easier to maintain. So let's create a class. We will create a class in a separate file. So let's create a new file. I press Ctrl+N to create a new file and then Ctrl+S to save this file as clock.py. This way, all the clock-related code stays in one place, making it easier to work with. Now let's define our class. Class analog clock : Then let's create the init method. Def __init __ self. Now let's think about what attributes and methods our class needs to have. We need to be able to set the size of the clock, so it will have a size attribute. Let's make it private. We add a size parameter to the init method, size here. And now let's assign this value to a private size attribute. Self.__size is equal to size. The size attribute represents the radius of the clock in pixels, and it will be used to determine the dimensions of the clock face. Next, we need to position the clock on the screen. For that, we will add a private attribute position to store the x and y coordinates of the clock's center. Let's add this to the constructor, position here, and self.__position is equal to position. For now, we also need two methods, an update method and a draw method. The update method will refresh the state of the clock by fetching the current time at every frame. The draw method will handle the rendering of the clock on the screen. Let's define these methods as placeholders for now, so we can implement them in detail later. Def update self pass. Def draw self pass. With these methods in place, our class structure is ready. Now let's work on the fun part. Let's create the clock face. As we said, the clock consists of some simple shapes. First, let's create the outer rim. Let's start implementing the clock face in the draw method. To do this, we will use Pygame's GFX draw module for smooth and anti-aliased shapes. Unlike the standard pygame.draw.circle function, which can produce jagged edges, GFX draw creates circles with smoother outlines, making the clock look more polished and professional. So first, let's import the Pygame and the GFX draw modules. Import Pygame. Import pygame.gfxdraw. We will need two colors for the outer rim, a dark gray and a light gray. Let's create them. Let's create them here. Dark gray is equal to 45, 45, 45. Light gray is equal to 229, 229, 229. Now in the draw method, let's draw the outer dark circle. That's very easy. We use gfxdraw.aa circle to create a smooth anti-aliased outline. Pygame.gfxdraw.aa circle . The first argument is the surface we want to draw on. We want to draw on the window surface we created in the main file. But the analog clock class cannot access this surface, so we need to pass it in as an argument to the draw method. So here we add window. Now we can use that surface in this method. A window here. Now we need to add the position of the center of the circle, self.__position brackets 0, self.__position brackets 1. Then we need the size of the circle, self.__size and the color of the circle, dark gray. Let's run the code so far to see our analog clock for the first time. Let's go to the main.py file. First, let's import the analog clock class. From clock import analog clock. Now let's create an analog clock object. Analog clock is equal to analog clock parentheses. Now we need to give the clock a size and a position. Let's give it a radius of 250 pixels and position it at the center of the screen. So we type here 250, parentheses, 300, 300. Now let's go to the main loop and call the update and draw methods of the object. Here, in the update part of the code, we call the update method, analogClock.update. And in the drawing part, after we clear the screen, we call the draw method, analogClock.draw, parentheses, window. And we have to pass in the surface we want to draw on. Perfect. Let's run our code. As you can see, a dark gray circle with no fill has appeared. But we want a thicker circle. Unfortunately, the gfxdraw.aa_circle function does not provide an option to directly set the thickness of the circle's outline. However, we can achieve the desired effect by drawing a filled circle first and then layering smaller circles with different colors on top of it. This approach creates the appearance of a thick two-tone rim while maintaining smooth edges. Let's go back to the clock.py file and implement this. First, we will create the filled circle. To do this, we copy the line of code that uses the AA circle, but instead of calling AA circle, we replace it with filled circle. This will fill the entire circle with the dark gray color, while keeping the edges smooth and anti-aliased. Let's run the code again. As you can see, we now have a filled dark gray circle with a smooth anti-aliased perimeter. Next, we will layer smaller circles on top of it to create a visually appealing two-tone effect. Back to the draw method. Let's create a smaller light gray circle on top of the dark gray one to add depth to the rim. This new circle will have a radius that is 30 pixels smaller than the dark gray circle. To do this, we can simply copy the two lines of code that draw the filled dark gray circle and modify them. We just change the size and the color. So I put in -30 here and here for the size and light gray for the color here and here. Let's go to the main.py file and run our code again. Now the new circle is drawn inside the dark gray one, creating a layered two-tone effect. This way, we created an outer dark gray rim which is 30 pixels thick. It is starting to look great. However, as we continue to add more features to the clock face, you'll notice that we are repeating the same logic for drawing circles. This repetition can make the code harder to read, maintain, and extend in the future. To improve our code, we can refactor it by creating a private method for drawing circles. This method will encapsulate the logic for drawing a circle, so we don't need to copy and paste the same lines of code multiple times. Here is how we can do it. Let's add a private method, drawCircle, to our class. This method will take the surface, position, size, and color as parameters and handle the drawing of a filled circle with anti-aliasing. So we type def __ drawCircle, parentheses, self, window, position, size, color, colon. Now we copy these two lines of code from here and we paste them here. Let's modify them like this. We remove the cell.__ from all the arguments and we replace this color with the color argument. Our method is ready. Now we can go back to the draw method and delete this code. We will use the new method instead. Self.__ drawCircle, parentheses, window, self.__ position, self.__ size, dark gray. Self.__ drawCircle, parentheses, window, self.__ position, self.__ size -30, light gray. Let's go to the main.py file and run the code again. Everything worked just as before, but now our code is cleaner and more efficient. Great job! Next, we will follow the same approach to add a white circle to create the main face of the clock. The white circle will be 10 pixels smaller in radius than the light gray circle, forming a clean and crisp background for the clock hands and the hour markers. Let's do it. First, let's create the white color variable. White is equal to, parentheses, 255, 255, 255. Now we simply use our new method in the draw function. Self.__draw circle, parentheses, window, self.__position, self.__size -40, white. Let's go to the main.py file and run our code again. Now we can see the full clock face with a dark gray outer rim, a light gray inner rim, and a clean white circle in the center. This design forms the foundation of our analog clock, providing a simple yet elegant structure for the rest of the clock elements. Before we wrap up step number 3, let's take one more step to improve our code. Right now, the logic for drawing the clock face is directly written in the draw method. While this works fine, it can make the draw method harder to read as we add more elements to the clock. To make our code cleaner and more organized, we will create a private method called drawFace. This new method will handle all the logic for drawing the clock face. So, in the clock.py file, we add a new method. def__drawFace, parentheses, cell, window. And we copy these lines of code from here inside this new method. Now we update the draw method to simply call this new method, self.__drawFace, parentheses, window. This refactor doesn't change how the program works, but it makes the draw method much cleaner. It also allows us to easily modify the clock face in the future without touching the draw method. Let's run the code one more time to ensure everything still works as expected. Perfect. The clock face looked just as it did before, but now our code is better organized and easier to extend. Refactoring like this is a great habit to build as a programmer, and it will help you keep your projects clean and maintainable as they grow. With that, we have officially completed step number 3. Great work! Our clock is starting to take shape. But as we dive deeper into this project, you will notice we will rely heavily on classes and object-oriented programming concepts to keep our code clean and organized. If you are not entirely confident with object-oriented programming yet, or you have ever wondered not just how to use classes, but why to use them, I've got you covered. My course, Object-Oriented Programming Made Easy, is designed to make object-oriented programming crystal clear. In just 3.5 hours, you will not only learn the key concepts like classes, inheritance, and polymorphism, but you'll also discover why object-oriented programming is a game changer for simplifying complex projects. Plus, in the course, we will build a fantastic project together, a digital life simulation. You will see firsthand how object-oriented programming transforms a complex idea into something surprisingly manageable and fun to code. It's the course I wish I had when I was first learning object-oriented programming, and I promise it will help you understand object-oriented programming once and for all. The link is in the description. Check it out and take your coding skills to the next level. Now let's move on to step number 4, adding the hour markers to the clock face. These markers are small rectangles that represent the 12 hours and are evenly spaced around the edge of the clock. They give structure to the clock and make it easy to read the time. Placing these markers evenly is a bit tricky because they need to be perfectly aligned at specific angles. Typically, this problem is solved using trigonometry. To simplify the process, we will take a different approach. We will use rotating surfaces. We will start by creating a new surface the same size as our window. In Pygame, a surface is like a blank canvas where we can draw shapes, images, or anything we want to display. On this surface, we will draw a single rectangle to represent a 1-hour marker. The rectangle will be positioned so that it starts at the center of the surface and extends to the edge of the clock's circle. Next, we will use Pygame's transform.rotate method to rotate this new surface to the right position for each hour. Since there are 12-hour markers, we will rotate the surface by 30 degrees for each hour. Rotating the surface instead of calculating the exact position for each marker makes things easier and ensures everything lines up perfectly. Once rotated, we will place the new surface onto the main window. After all the markers are in place, we will clean up the center of the clock by drawing a white circle on top. This will cover the parts of the markers that extend into the center, leaving only the outer parts visible along the edge of the clock. This method keeps the design simple, clean and professional. Let's get started. In our init method, we will create a new surface that matches the size of the main window. Since we don't know the size of the window ahead of time, we will take it as an argument when initializing our clock. This will allow us to dynamically set up the surface to match the window's dimensions. Here is how we will update the init method to include the window size. We will add two arguments here, window width, window height. Now we can create a private rotation surface attribute like this. Self.__rotation surface is equal to pygame.surface window width, window height, pygame.source alpha. The source alpha flag is used to enable transparency, so the surface doesn't block other elements when we bleed it onto the window. Now that we have set up the surface, we can move on to drawing the hour markers. To keep our code clean and organized, we will create a new private method called drawOurMarks. This method will handle all the logic for creating and positioning the hour markers, keeping the draw method simpler and more focused. By making this method private, we ensure that it is only used internally by the analog clock class, as the hour markers are an essential part of the clock's design. This separation of concerns makes our code easier to maintain and extend in the future. def__drawOurMarks self, window, colon. Now let's implement this method. First, we need to set up the dimensions for each rectangle. The width of the rectangle will be 10 pixels to make the markers thin, while the height will match the radius of the clock, so the markers stretch from the center to the edge. Let's define these dimensions. Rect width is equal to 10 and rect height is equal to self.__size. Next, we need to calculate the position of the rectangle so that it starts from the center of the clock. The x-coordinate will center the rectangle horizontally, while the y-coordinate will place it vertically. Rect_x is equal to self.__position (0) minus rect width //2. Rect_y is equal to self.__position (1) minus rect height. Now that we have defined the dimensions and position for a single rectangle, we can use a for loop to draw all 12-hour markers evenly around the clock face. Each marker will be rotated by 30 degrees to align it correctly for each hour. For I in range (12) : Before drawing each marker, we clear the rotation surface to ensure transparency and avoid overlapping from previous iterations. Self.__rotation surface fill (parenthesis) 0, 0, 0. Next, we need to draw the rectangle for the current hour marker on the cleared surface. We will use pygame.draw.rect function to draw the rectangle at the calculated position. Pygame.draw.rect self.__rotation surface, dark gray, rect x, rect y, rect width, rect height. This line draws a rectangle on the rotation surface. It specifies the surface to draw on, the rectangle's color, and its position and size using a tuple. The rectangle represents an hour marker, thin and vertical, extending from the clock center to its outer edge. After drawing the marker, we will rotate the entire surface to place the marker at the correct angle for the current hour. We use Pygame's transform.rotate function to do this. Rotated surface is equal to pygame.transform.rotate, parenthesis, self.__rotation surface, 30 times I. This rotates the entire surface by 30 by I degrees, where I is the current hour index. However, we need to be careful here because the rotated surface does not retain the same size as the original rotation surface. When a surface is rotated, its size increases to accommodate the rotated content, ensuring nothing is clipped. To correctly align the rotated surface with the clock's center, we use its getRect method. Rotated rect is equal to rotated surface dot getRect parenthesis center equals self.__ position. The getRect method calculates a new rectangle that defines the boundaries of the rotated surface, and this argument here ensures that this rectangle is aligned with the center of the clock. Finally, we add the rotated marker to the main window. Window.bleed parenthesis rotated surface, rotated rect. By repeating this process in the loop, we create 12 evenly spaced and accurately positioned hour markers around the clock face. Now we are almost ready to run our code. Let's call this method inside the draw method. Self.__draw hour marks parenthesis window. Now let's go to the main.py file. Before running our code, we have to modify this line of code, which creates the analog clock object. The constructor now requires that we pass in the window width and window height. So we add here window width, window height. If everything is implemented correctly, you should see all 12 rectangles perfectly spaced and aligned around the clock face. Awesome work! Our hour markers are in place. Now, as we discussed earlier, let's draw a white circle to erase the center portion of the hour markers. This will clean up the clock face by hiding the overlapping parts of the markers that extend into the middle of the clock. To do this, let's go back to the draw hour marks method and add a line to draw a smaller white circle on top of the hour markers. Self.__draw circle parenthesis window. Self.__ position, self.__ size -60, white. This circle, slightly smaller than the clock face, neatly covers the inner parts of the markers while leaving the outer portions intact. Now let's run the code again. Perfect. Our hour markers are ready, completing step number 4 of our project. Great job so far. We are making excellent progress, and believe it or not, the most challenging part of the code is now behind us. Next, let's move on to step number 5, adding the minutes hand. Now let's bring our clock to life by adding the first of its 3 hands, the minute hand. To create it, we will use a similar approach to the one we used for designing the hour markers in the previous step. On the new surface we created earlier, we will draw a rectangle to represent the minute hand. This rectangle will be thin and long, starting from the clock's center and extending outward to just below the edge of the clock face. After drawing the rectangle, we will use Pygame's rotate method again to rotate it to the correct position based on the current minute. This rotation ensures the minute hand points to the appropriate spot on the clock face. Finally, we will align the rotated surface with the clock's center and display it on the main window. Let's update the analog clock class by adding a private method called drawMinuteHand. This method will handle the logic for drawing, rotating, and displaying the minute hand. Def drawMinuteHand parenthesis self, window, minute, colon. First, let's define the hand width and length. Hand width is equal to 10. Hand length is equal to self.__ size times 0.7. We make the length of the hand slightly shorter than the clock's radius. Next, we calculate the position of the rectangle so that it starts from the clock's center and stretches outward. To do this, we determine the top left corner of the rectangle. Rect x is equal to self.__ position 0 minus hand width // 2. Rect y is equal to self.__ position 1 minus hand length. Here, rect x centers the rectangle horizontally while rect y positions it vertically. Now we need to clear the rotation surface to ensure there is no leftover content from previous frames. Self.__ rotation surface dot fill parentheses, again parentheses 0, 0, 0, 0. This clears the surface with transparency, making it ready for the new minute hand. Next, we draw the rectangle representing the minute hand on the cleared surface. Pygame.draw.rect parentheses self.__ rotation surface, dark gray, parentheses rect x, rect y, hand width, hand length. This creates a thin vertical rectangle starting at the calculated position. After the rectangle is drawn, we need to rotate the entire surface to align the minute hand with the correct position on the clock face. To determine the rotation angle, we use the fact that the clock face is a full circle, divided into 60 minutes. Each minute corresponds to an equal portion of the circle, 6 degrees per minute. This means the minute hand moves clockwise by 6 degrees for every minute that passes. To calculate the exact angle for the current minute, we multiply the minute value by 6. However, since the rotate method in Pygame rotates surfaces counterclockwise by default, we need to apply a negative angle to achieve a clockwise rotation. Here is how we can do it. Rotated surface is equal to pygame.transform.rotate parentheses self.__ rotation surface, minus 6 times minute. Now we align the center of the rotated surface with the clock's center. Rotated rect is equal to rotated surface dot get rect parentheses center is equal to self.__ position. This ensures that no matter how the surface size changes during rotation, it remains properly aligned. Finally, we display the rotation surface on the main window. Window.bleed parentheses rotated surface, rotated rect. With this logic in place, the minute hand is dynamically drawn, rotated, and displayed. To test the minute hand, let's update the draw method to call the draw minute hand method and pass in a sample minute value. For example, we can use a fixed value like 15 to check if the hand points correctly to the 15-minute mark on the clock. Self.__ draw minute hand parentheses window, 15. Let's go back to the main file and run the code again. Beautiful, our minute hand works. Let's use another value for the minute to ensure that the hand aligns correctly with different positions. For example, we can test with a value like 30 to see if the hand points to the 6 o'clock position. We go back to the clock.py file and change this value to 30. Let's run the code one more time. It works. With the minute hand complete, we are one step closer to a fully functional analog clock. Next, let's move on to adding the hour hand, which follows a similar logic but requires a slightly different rotation calculation. The hour hand will be represented by a rectangle that is shorter and thicker than the minute hand, making it visually distinct. This rectangle will extend from the center of the clock and point to the appropriate hour mark on the clock face. The key difference lies in how we calculate the rotation angle for the hour hand. Since the hour hand represents 12 hours on the clock, the full circle of 36 degrees is divided into 12 parts. This means that for every hour, the hour hand rotates 30 degrees. However, the hour hand doesn't jump directly from one hour to the next. It gradually moves as time progresses. To achieve this smooth transition, we also consider the fraction of the current hour based on the minutes. For example, at exactly 3 o'clock, the hour hand points to 90 degrees. 3 times 30 At 3:30, the hour hand points halfway between 90 degrees and 120 degrees. 3 times 30 plus 15 degrees for the minutes. To calculate this rotation, we use the formula. Rotation angle is equal to 30 times hour plus minute over 60 times 30. With this calculation, the hour hand will always point to the correct position, smoothly transitioning between hour markers based on the current minute. If we take a closer look, we can see that most of the logic for drawing the hour hand is identical to the minute hand. The only differences are the dimensions and angle calculations. To avoid repeating the same logic, we will create a generic method called drawHand. This method will take parameters for the hand's width, length, rotation angle, and color, allowing us to reuse it for both the hour and minute hands. Let's define it. Def __ drawHand, parenthesis, self, window, hand width, hand length, angle, color, colon. Now let's copy this block of code, which will be similar for both methods, and paste it here. There are only a couple of changes to make. We replace the hard-coded color with the color argument. This allows the method to work for hands of any color. We also replace the hard-coded angle with -angle. In Pygame, rotations are counterclockwise by default, so to rotate the surface clockwise, we use the negative value of the angle. That's it, our new method is ready. First, let's refactor the existing drawMinuteHand method to use the new generic drawHand method. Instead of repeating the rectangle drawing and rotation logic, we will simply pass the appropriate parameters to the drawHand method. So we delete this part of the code and we simply type self.__drawHand, parenthesis, window, hand width, hand length, minute times 6, dark gray. Let's test our code one more time to ensure the refactored drawMinuteHand method works as before. Perfect. Everything is functioning as expected. Now let's move on to creating the drawOurHand method. Def ___ drawOurHand, parenthesis, self, window, hour, minute. In this method, we will define the width and the length of the hour hand to make it visually distinct from the other hands. Hand width is equal to 15. We want this hand to be thicker. Hand length is equal to self.__size times 0.6. We want this hand to be shorter. Next, we calculate the rotation angle for the hour hand. As we discussed earlier, the hour hand moves 30 degrees for each hour and transitions smoothly based on the minutes. The formula is this. Angle is equal to 30 times hour plus, parenthesis, minutes over 60 times 30. Now we use the generic drawHand method to draw the hour hand. Self.___ drawHand, parenthesis, window, hand width, hand length, angle, dark gray. Let's update the draw method to test the hour hand along with the minute hand. Self.__ draw hour hand, parenthesis, window, 3, 30. Now let's go to the main.py file and run the code one more time. Great. As you can see, we now have both hands appearing on the screen. Another step is now complete. We have just 2 steps to complete our project. We are making great progress. The next step in our list is to draw the second hand. Again, we will use a similar approach. We will draw a rectangle on a separate surface and we will rotate the surface every second. Let's do it. We will start by creating a new method in the clock.py file. Def___ draw second hand, parenthesis, self, window, second, colon. Now let's set the width and the length of the hand. Hand width is equal to 5. I'll make the length of the hand slightly larger than the clock radius. You will see why I do that in a minute. Hand length is equal to self.__size times 1.05. Next, we need to calculate the angle for the second hand. Since the clock phase is divided into 60 seconds, each second corresponds to a 6-degree rotation. The formula is straightforward. Angle is equal to second times 6. Now we use the draw hand method to draw the second hand. Self dot draw hand parenthesis window, comma, hand width, comma, hand length, comma, angle, comma, quotes red. Let's test our new method. In the draw method of our class, let's call the new method to draw the second hand. Self dot underscore underscore draw second hand parenthesis window, comma, 0. Now let's go to the main file and run our code again. Perfect. The second hand appears. However, if we take a closer look at how the second hand is designed in our original concept, we can see that it is slightly off. The second hand currently rotates from its left edge, which isn't correct. It should rotate from a point slightly offset between the left edge and its center. To fix this, we will introduce a small offset in the y-axis when positioning the second hand rectangle on the rotation surface. This offset will ensure that the second hand rotates from its intended pivot point. To achieve this, let's modify the draw hand method. We will add an offset parameter to the draw hand method, comma, offset equals 0. The offset parameter will adjust the y-coordinate of the top left corner of the rectangle for the second hand. By setting a default value of 0, this change won't affect the minute and hour hands unless explicitly specified. Next, we will update the calculation for the rectangle's y position to include the offset, so we add plus offset here. This ensures that the rectangle's position is adjusted appropriately, applying the offset only when needed. For the minute and the hour hands, we won't pass any value for offset, allowing them to use the default value of 0. However, for the second hand, we will pass a non-zero offset value such as 10 to shift it slightly down and align its rotation point correctly. With this simple adjustment, the second hand will now rotate accurately from its intended pivot point, while the behavior of the minute and hour hands remain unaffected. Now let's modify the draw second hand method to include the offset. We will pass a non-zero offset value when calling the draw hand method for the second hand. Let's add an offset of 55 pixels, comma 55 here. Let's go to the main file and run our code one more time. Perfect. The hour and minute hands are unaffected and the second hand is slightly offset. All our hands are now ready. To further enhance the appearance of our clock, let's add a small dark gray circle at the center. This circle will cover the base of the hands rectangles, giving the clock a clean and polished look. Let's go back to the draw method and add this circle after we have drawn all the hand elements. We will use the draw circle method we created earlier. Self.__draw circle parenthesis window, comma, self.__position, comma, 15, comma, dark gray. This creates a circle with a radius of 15 pixels, centered at the clock's middle using a dark gray color. Now let's go to the main.py file and run the code one more time. Perfect. The new circle hides the base of the hands and our clock now looks neat and polished. Congratulations on making it this far to the tutorial. We have successfully completed step number 7. Now there's just one final step to finish our clock, and it is the easiest one yet. All that is left is to fetch the current time and set the hands to their correct position. Let's bring our clock to life. To fetch the current time, we will use Python's datetime module. This module makes it easy to get the current hour, minute, and second. Let's modify the update method in the analog clock class to handle this. First, let's import the datetime module. At the top of the file, we add from datetime import datetime. The datetime module provides various functions for working with dates and times. Here we will use the datetime.now method to get the current date and time. Now let's create 3 new attributes to hold the current hour, minute, and second. In the init method we add self.__hour is equal to 0, self.__minute is equal to 0, and self.__second is equal to 0. We initialize these attributes with default values of 0. These will be updated dynamically in the update method. Now let's modify the update method to set these attributes to the current time. Inside the update method, we add now is equal to datetime.now. This line retrieves the current dated time and stores in the now variable. The now object contains information like the current hour, minute, second, and more. Now let's get the hour. Self.hour is equal to now.hour%12. Here we extract the current hour from the now object. Since now.hour returns the hour in the 24-hour format, we use the modulo operator to convert it to a 12-hour format. This ensures the clocks display hours from 1 to 12, like a traditional analog clock. Now let's get the current minute and second. Self.__minute is equal to now.minute. And self.__second is equal to now.second. To make the clock hands reflect the current time, we need to modify the draw method. Instead of using static values for the hour, minute, and second, we will use the time attributes we just created. So I modify the draw method like this. Self.__minute here, self.__hour, self.__minute here, and self.__second here. Our code is ready. Let's test it out. The clock now updates dynamically to reflect the current time. All the hands move smoothly and correctly, and the clock looks polished and functional. Congratulations, you have completed the project. Fantastic work! You have just built a fully functional analog clock with Python and Pygame. It is not only a great project to showcase your programming skills, but it is also a solid introduction to concepts like drawing, rotation, and working with time in Python. If you enjoyed this tutorial and found it helpful, don't forget to like this video and subscribe to my channel for more fun and educational programming projects. Your support helps me create more tutorials like this one. If you are ready to take on a more advanced challenge, why not check out my tutorials on building Tetris or Space Invaders? These projects dive deeper into game mechanics, logic, and even some advanced graphics techniques. They are perfect for leveling up your skills while having fun building classic games. Thanks for watching, and I'll see you in the next tutorial. Happy coding!